everyone, welcome to week 13 of quality quant questions. This week we'll be taking questions from linear equations. Hopefully you have attempted the questions before watching the video. Let's start right away. Kishan takes up an assignment for a month at a crafts village where he's assigned to make a piece of pottery every day. For every non-defective piece, he's paid 80 rupees, while for a defective piece, he pays back rupees 80. If at the end of the month, Kishan earns a net amount of 1,580, the number of defective pieces he made is. Now understand, there are two challenges here. First, of course, we have to figure out how many defective pieces he made. But we are told for a month. And the duration of a month is not fixed. You could have number of days in a month as 31, or number of days in a month as 30, or number of days in a month as 29, or number of days in a month as 20. All of these can potentially work. All of these can potentially work. Now, how do you go about solving it? Let's say, let the number of days in a month be k. Let the number of days in a month be k. Now, if he had not made a defect, if he had not made a defective piece on any day, the amount of money he would have earned, is 80k. This is the amount of money he would have earned if he had never made a defective piece. This is the amount of money he would have earned if he had never made a defective piece. Every day, if he made proper pieces, he would have earned 80k. But now, look at a particular day. One day is receiving 80. If on one day, instead of a non-defective piece, he made a defective piece, how much money is he losing out on? He's losing out on the 80 he would have earned, and he has to pay back 80. So he's losing out on 98 rupees. So 80k minus 98n should be equal to his final earning in the month. 80k minus 98n should be equal to 1518. Now, first thing I'll do is I'll remove 2's from this expression. I get 40k minus 49n equal to 759. Now understand, for us to solve this, and because this is a theta question, there is going to be one solution. I have to plug in different values of k and see where my n turns out to be integral. Wherever my n is acceptable, that is going to be the case. I'll start off by putting k as 31. 40 into 31 is 1240 minus 49n is equal to 759. This is when k is equal to 31. Or 49n is equal to 8 months. 1181 minus 700. So 481. This is not an acceptable state. This is not an acceptable state because now, can you see the value of variable n will turn out to be a non-integral number. I hope I've done it correctly. 3 minus 5, 8, then 11 minus 7. Yes, it's fine. Let us now check at k equal to 30. We'll get 1200 minus 49n is equal to 759. It gives us 49n should be equal to 441. This is wonderful because this gives us n is equal to 9. 49 into 9 is 441, 21 square, I recognize. And ideally, if I was in an exam, at this point, I would have marked my answer to the question as 9 and moved on. I would have marked my answer to the question as 9 and moved on. Because again, this is a theta question and I found one acceptable case, all my working is done. But because this is an explanation video, we will check the other cases also. When k is 29, We will have 1160 minus 49 is equal to 759, which gives us 4910 is equal to 401. Not an integral result. Finally, when k is equal to 28, 1120 minus 49 is equal to 759, which gives us 49 is equal to 361. This is also not giving us an integral result. So out of the 4 possible values of k, because k can take only one possible value, which is 30, because k can take only one possible value, which is 30, the answer to the question, the number of defective pieces he made is 89. Next question now. A salesman gets a commission of 10 rupees, 2 rupees, and 1 rupee for selling each of the 3 products, A, B, and C respectively. On a particular day, he sold 4 times as many items of C as items of B and earned a total commission of rupees 100. The maximum number of items of A that he could have sold is. Okay. Let's say for product A, he sold A items, small a, B for B, and 4B for C. Because we know he sold 4 times as many items of C as items of B. So this is B, this is 4B. Now the commission he would have earned is 10A plus 2B plus 4B, and this all has to be equal to 100. Together I get 10A plus 6B is equal to 100. Now see this wonderful thing. This is a multiple of 10. This is a multiple of 10. So by extension, 6B should be a multiple of 10. In order to be a multiple of 10, you need a 2 and a 5. 2 is already present in 6. 2 is already present in 6. So can I say B has to be a multiple of 5? B has to be a multiple of 5. Now, my final question was the maximum number of items that A that could have. I want to maximize this. If I want to maximize this A, I have to minimize this B. B has to be a multiple of 5. And the smallest possible multiple of 5 that I can assign to B is 5 itself. Should mean 10A plus 30. B is equal to 5 is equal to 100, or it gives me A is equal to 7. A is equal to 7. So maximum number of items of A that we could have sold is 7. Now somebody may have a question. Why does this B have to be a multiple of 5? It could very well be 0, and even then our equation would work. The problem with that would be, see, on a particular day, he sold 4 times as many items of C as items of B. If I take the value of B as 0, B and C, both of them would set 0 amounts. 0 amounts. And then that is an unacceptable situation, because you cannot have, if you sold 0 units of B and 0 units of C, you can't say C sold 4 times as many units as B. That statement would become faulty. The answer to the question is, of course, 7. Next question now. Pradyuman bought some French, Spanish, and German magazines, at least one of which. The magazines are respectively priced at 120, 250, and 150. He had bought a total of 40 magazines for a total amount of 7,100. Okay. If Pradyuman bought the minimum possible number of German magazines, how many French magazines did he buy? Find the number of Spanish magazines Pradyuman bought if the number of German magazines he bought is the maximum possible. Okay. So in both the subparts, German magazines are the one with which we have to play our game. First, I'll say number of magazines he bought of French, let that be F. Of Spanish, let that be S. Of German, let that be G. The first equation we have is F plus S plus G is equal to 40. Because he bought a total of 40 magazines. Now, price-wise, we get 120 F plus 250 S plus 150 G is equal to how much? 7,100. I can simplify this by simply getting rid of the zeros. I can also infer certain interesting things. I know that f has to be a multiple of 5 because 25s will be a multiple of 5, 15g will be a multiple of 5. If I'm reaching a total of 710, f has to necessarily be a multiple of 5. So I can right away rule out these two options. They are definitely not happy. Has to be a multiple of 5. I know f has to be a multiple of 5. Okay. Now, how to identify minimum possible and maximum possible German magazines? I can either eliminate this Spanish magazines entirely or French magazines entirely. Then I can get to my cases. I'm choosing to eliminate French magazines because they're smaller. On the first one, I'll get 12F plus 12S plus 12G is equal to 480. What this gives me now is French is gone entirely. I'm left with 13S plus 3G is equal to 230. 13S plus 3G is equal to 230. Now, 110 minus. Okay, this is done. Now, I'm going ahead and writing down possible cases. This is 17. 13 into 17 is 221. This is 3. The next possible case is, and correspondingly, when I have my count of Spanish and German magazines, I will have my count of French magazines as well. This is 17, this is 3, and I know F plus S plus G is 40. French magazines will be 20 here. And this is great. I know the answer to the first part already. 20 was the highest number available, and I found a case where French magazines are 20. The next case, based off on this equation, is when S will go down by 3 and G will go up by 13. This will become 14. This will become 16. 3 down, 13 more. 16 and 14 adds up to 30. So this will be 10. Okay. Next case is when S goes down by 3, becomes 11. G goes up by 13, becomes 29. 11 plus 29 is already 40, which would mean French magazines would be 0. But I cannot have French magazines as 0 because I was given the condition at least one of each. So it's an unacceptable case. And if this is an unacceptable case, no case after this is going to be acceptable. No case after this is going to be acceptable. So these are the only two cases possible. So when we are told if Pradhiman bought the minimum possible number of German magazines, this case is being referenced. How many French magazines did he buy? 20. Find the number of Spanish magazines Pradhiman bought. If the number of German magazines he bought is the maximum possible. So this case is being referenced now. Here, how many Spanish magazines do we have? We have 14 Spanish magazines. So option C will work. And that is the entirety of this question set. Next question now. A dealer in refrigerators stocks refrigerators of 3 companies: Godrej, Kelvinator, and Bulb. He has a total of 27 refrigerators with him, costing a total of 6 lakhs. The unit prices of refrigerators are as follows. Godrej, Kelvinator, Whirlpool, we have the prices given. He has more than 3 refrigerators of each company and does not have the same number of refrigerators of any 2 companies. Okay. The first subpart is the total number of refrigerators of Godrej and Kelvinator with the dealers. This is a huge clue. The fact that this question is theta tells us that we will get a unique case here. We will get a unique case. Okay. Let's go ahead. Try to solve this. Equation wise, we have Godrej G, Kelvinator K, Whirlpool W. G plus K plus W is equal to 27. And then we have prices also mentioned. Now, when prices are mentioned, the first thing I'm doing is getting rid of 3 zeros from each of these numbers straight away. In fact, not just that, I'm also getting rid of 5s. So I'm getting 3G plus 4K plus 5W is equal to 120. This way, my equation handling is easy. But remember, there is something wonderful that is told. There's absolutely something wonderful that is told. We are told, that three items of each of these three variants is already present. Three items of each of these variants are already present. So I'm saying, let G be equal to A plus 3. Let this be equal to A plus 3 and more than 3 refrigerators. So I'm not writing it as A plus 3, I'm writing it as A plus 4, A plus 4, and C plus 4. This way, when I'm solving my equations, A plus B plus C will become the primary equations. And then each of these variables can also take the values in. Right now, let us work. I'll get G plus K plus W is equal to 27, 4, 4, 4. This will translate to A plus B plus C is equal to 15 now. These three variables. Then 3 times of A plus 4, or I can write it straight away. 3A plus 4B plus 5C. Now 3 into 4 is 12. 4 into 4 is 16. 5 into 4 is 20. 12 plus 16 plus 20 is 48. 120 minus 48 is 72. This is the set of equation that we are looking to solve. Let's go ahead. First thing we'll do is 3ABC, 3A plus 3B plus 3C is equal to 45. So we'll get B plus 2C is equal to 27. This is the equation that you're solving for. I am free of the constraint more than 3 refrigerators. More than 3 refrigerators, I've already guaranteed. My challenge now is to ensure that same number of refrigerators of any two companies that does not exist. Okay. First case I can see here is if C is 13, if C is 13, then B will be 1. I know A plus B plus C is 15. So if this is 13, this is 1. This will also be 1, which makes this an unacceptable case. Cannot work. How about the next one? If I keep C as 12, B will be 3. So 12, 3, and 2. All conditions are met. All conditions are met. 2 into C, B into 3, and 2 into 12 is 24, plus 3 is 27, and so on and so forth. Everything is fine. Now, understand. This does not mean Godrej had 2 refrigerators. It means Godrej had 6 refrigerators. Kelvinator had 7 refrigerators. And Whirlpool had 16 refrigerators. This count we've got. But just to be certain or show you that no further cases can be made, see 2C into 2 into C will make it 11. 2 into 11 gives me 22. 2 into 11 gives me 22. This will become 5. 11 plus 5 makes it 16. And I know A plus B plus C had to be equal to 15 only. This is exceeding 15 already, which it would imply. Sorry. This is not 2. This is 0. 13 plus 1 plus 1, 12 plus 3 plus 1, 12 plus 3 plus 0. 11 plus 15 is already 16. It is already exceeding 15. So it will have to be minus 1. And this is, of course, impossible. So this is the only acceptable case. A has to be 0. So number of refrigerators of Godrej are 6. B is 3. So number of refrigerators, how is it 6? It is only 4. 0 plus 4 is 4. Number of refrigerators of Kelvinator are 7. And number of refrigerators of Whirlpool are 16. 16 plus 7 plus 4 is indeed 27. So yes. Now, when they're asking me the total number of refrigerators of Godrej and Kelvinator with the dealer, it is 4 plus 7. Answer should be 11. And which company's refrigerators did the dealer stock the most? The answer will be option C, one. Hopefully you understand. Because of this constraint, I was able to translate. Let the number of refrigerators of Godrej be equal to A plus 4, B plus 4, and C plus 4. These standard equations that I had, I was able to transform them and do my subsequent processing on simpler variables. Okay. Next question now. Deepti has 49 stamps, which are of 1 rupee, 50 paise, and 25 paise denominations. The total value of her stamps is 23 rupees and 50 paise. If the number of 25 paise stamps is greater than the number of 50 paise stamps and 1 rupee stamps together, and the number of 25 rupee stamps is less than 50 paise stamps, number of 1 rupee stamps is less than 50 paise stamps, then how many more 25 paise stamps than 1 rupee stamps does Deepti have? Things I know. If this is A, this is B, this is C. So first equation is A plus B plus C is equal to 49. If the number of 25 paise stamps is greater than the number of 50 paise stamps and 1 rupee stamps together, C is greater than half, greater than the majority. C is in the majority, A and B are less than C, which is to say, I can say C has to be greater than equal to 25. C has to be greater than equal to 25. C is the largest out of the lot, and C has to be greater than equal to 25. Additionally, we are told the number of 1 rupee coins is less than 50 paise stamps, which means A is less than B. I also know C is the greatest one, so I can perhaps conjure it up to A is less than B is less than C. Additionally, value of these stamps would be 100A plus 50B plus 25C is equal to 2350. I can get rid of 25s everywhere. We'll get 4A plus 2B plus C has to be equal to 94. Okay. So now I can get rid of C. But given the fact that C is the only variable for which I have a special condition of value, I don't want to eliminate C. What I do want to eliminate is some other variable. So I can either multiply the first equation by 4 or multiply this first equation by 2 to eliminate some other variable. I am choosing to multiply it by 2. The working would be easier. I would get 2A plus 2B plus 2C is equal to 98. And here, the first equation minus the second equation would give us 2B gone. C minus 2A is equal to C minus 2A is equal to 4. C minus 2A is equal to 4. And now we can come up with our solution sets. Now we can have our solution sets. B I will write separately. C minus 2A. I know C, smallest possible value that C can have is 25. See, if I put it down 25 here, see, this is even, so C has to be even only, so C has to be at least 26 now, not just 25, it has to be 26 now. So if it is C is 26, if C is 26, A would have, 2A would have to be 22 or A would have to be 11. 26 plus 11 adds up to 37. 26 plus 11 adds up to 37. And therefore, B will be 12. This seems like a perfectly acceptable storyline. C being 26. Let us check the next case. What would happen? If C is 28, C has to be even. C is 28, then A would have to be 12. This is 28, this is 12. This would have to be 9. The problem with this is, remember, A had to be less than B. Here, B is less than A. This is an unacceptable case, or any case created after this is going to be bad. So this is the only case that works. Final question was, how many more 25 paise stamps than 1 rupee stamps does Deepti have? C minus A is being sought. If C minus A is being sought, 26 minus 11. The correct answer to the question is option A, 50. Okay. Next, in an acute angled triangle in which the measure of all angles in degrees are natural numbers, 14 times one angle equals 19 times one of the other angles. The measure of the largest possible angle in degrees in the triangles. Okay. So let's call it angle 1, angle 2, and angle 3. If we're told 14 times one angle equals the 19 times one of the angles, can I say 14 times angle 1 is equal to 19 times angle 2? So angle 1 by angle 2 is equal to 19 by 14, or 19x, 14x. And what is left for the third angle is going to be 180 minus 33x. 180 minus 33x, because these are three angles of a triangle, and sum of angles, three angles of a triangle is going to be 180 only. Now, I can go ahead and put it down. I can put down values of x until I keep getting reasonable cases. So x at x equal to 1, I'll get 19, 14, 180 minus 33 is 147. But this is an unacceptable case, because we were told in an acute angle triangle, this would make it an obtuse angle triangle. This does not work. How about x equal to 2? This becomes 38. This becomes 28. 38 and 28 is 66. Is 66. So this should be 114. Again, this is an obtuse angle triangle, doesn't work. How about x equal to 3? This will now become 57. This will become 42, 99, 1. This will be 81. All three angles are indeed acute angles. This is an acceptable case. Next case is going to be x equal to 4. It's going to be 76. This is going to be 56. This is going to be 48. Then this is also an acceptable case. At x equal to 5, this will become 95, which makes it an obtuse angle triangle. Which means the only two acceptable cases are these. Finally, the question is the measure of the largest possible angle. Measure of the largest possible angle in degrees of the triangles. In this case, I have 81. In this case, I have 76. Of course, 81 is larger than 76. So answer to the question will be 81. Next, Raman wants to purchase 3 different varieties of chalk pieces. Dust-free variety, low dust variety, and regular variety. He decides to buy twice as many boxes of low dust variety as the dust-free variety, and at least one more box of dust-free variety than the regular variety. He finds that dust-free variety are thrice as expensive as regular variety, and regular variety are half the price of low dust variety. The cost of a regular variety is ₹10, and Mr. Raman spends a total of 470. Then how many boxes did he buy? Okay, let's start. I have a dust-free variety, I have a low dust variety, and I have a regular variety. 3 things. First, I have to worry about quantity. Then I have to worry about price. The wonderful thing about price is cost of the regular variety is 10 rupees. Price is already given to me as 10 for regular variety. And he finds that the dust-free variety is thrice as expensive as regular variety. Dust-free varieties, 3 times of this, price is 30. And regular variety are at half price of low dust variety. So this is 20. The prices are known to us. Now we are also told he decides to buy twice as many boxes of low dust variety as dust-free variety. So if this is X, this is 2X. This is X, this is 2X, and he decides to buy twice as many boxes of low dust variety as dust-free variety, and at least one more box of dust-free variety than the regular variety. So the number here let's call it y. Let's call it y. I know y has to be less than x. At least one more box of dust-free variety than regular variety. Y, the number of boxes of regular variety bought is y. The y has to be less than x. Now the costs involved are going to be 30x, 40x, and 10y. Or altogether 70x plus 10y. This has to be equal to 470. 7x plus y has to be equal to 47. Okay. So now looking at the first solution set is of course 6. First solution set is of course 6, and then this will be 5. 7 into 6 is 42, y is 5. Next solution set is going to be x being equal to 5, this being equal to 12. And this is an untenable situation because we know y had to be less than x, which means this is the only possible case. This is the only possible case. X is 6, y is 5. Dust-free variety, 6 boxes were bought. No dust variety, 12 boxes were bought. Regular variety, 5 boxes were bought. 6 plus 12 plus 5. How many boxes did he buy now? It is 23 boxes. Next question now. The number 72 can be divided into 3 positive parts, of which one is a multiple of 5, another is a multiple of 8, and third is a multiple of 13. In how many ways can this be done? Okay, we have 5x plus 8y plus 13z is equal to 72. This is what is told us. This is what is told us. Now, how you come up with different solutions? How many ways can this be done? Is as good as asking how many solution sets will exist if x, y, z are natural numbers. Remember, these are 3 positive parts, so none of these variables can take 0 or negatives. Okay. First thing we do is look at the largest coefficient for the 3 variables. 13. Can I say 13? Z can therefore take values from 1 to 5 only. These are the only possible values that Z can take. If Z becomes 6, it will become more than 72. And Z, of course, cannot take 0. So, we'll start off with when Z is equal to 1. The equation left is 5x plus 8y is equal to 13, 1 from here, 15, 9. Is 59. So now we have to check any acceptable solution set that we can create. 24 plus 35 will work. 7. 3. One solution set when Z is 1. This is happening. The next solution set that gets created would have y. Sorry. The next solution set would be either x goes up by 8 or goes down by 8, and y correspondingly will go down by 5 or up by 5. If it goes down by 8, it will turn negative. If it goes up by 8, if it goes up by 8, it will become 15. But then y would have to go down by 5, even minus 2. This is unacceptable. We cannot have a solution set like this, which means this is the only case when z is equal to 1. How about when z is equal to 2? Z is equal to 2. You have 5x plus 8y is equal to 72 minus 26. So 46. We have to find the solution set for this now. Okay. How I'm creating the solution sets? Understand? I know that 59 is 5n plus 4 kind of number. Leaves a remainder of 4 with 5. So I'm looking for a multiple of 8 that leaves a remainder of 4 with 5. Because I saw it was doing it at 24. So 8 into 3 corresponding value of 7 was identical. Here remainder with 5 is 1. So 8, some multiple of 8 leaving a remainder of 1 with 5. It is of course 2. 8 into 2 is 16. 16 is used up here. X will be 6. Okay. Z being 2, Y being 2, and X being 6. Yes, this is also a solution set. Now again, Y cannot become 5 lesser, X cannot become 8 lesser. Both of these are the entire limit. We cannot have any more cases. Let us check it. Z equal to 3. I will have 5x plus 8y is equal to 33. I need some multiple of 8. I need some multiple of 8 that leaves a remainder of 3 with 5. 8 itself. Y equal to 1. X equal to 5 would work. So 3, 5, 1. One more solution set has been identified. Y cannot go down 5. X cannot go down 8. Yo. How about Z equal to 4? At Z equal to 4, I'd have 5x plus 8y is equal to 20. Now see, this is a multiple of 5. This is a multiple of 5. 8y also has to be a multiple of 5. The smallest multiple of 5, that is also a multiple of 8, is 40, which would mean x will have to take a negative value. I cannot create an acceptable case here at all. And at z equal to 4, I'll get 5x plus 8y is equal to 7. Not z equal to 4. At z equal to 5. No positive solution set can be created here either. So there are 3 solution sets possible. X being 7, Y being 3, Z being 1, or 6, 2, 2, or 5, 1, 3. These are the 3 solution sets that are possible. The answer to this question is option A. Next question. There are 2 groups of people, A and B. If some members in B join A, the number of members in A is 3 times the number of members in B. Okay. If the same number of members in A join B, if the same number of members in A join B, the number of members in the 2 groups is equal. The total number of members in the 2 groups lies between 35 and 45. Find the number of members in group B. Okay. First thing you have to understand here is you can do it via algebra, but there is also a very huge number theory clue present. Look at this clue. If some members in B join A, the number of members in A is 3 times the number of members in B. If some members in B join A, the number of members in A is 3 times the number of members in B. What this translates into is the total count of people across 2 sections. If they can be divided in the ratio 3:1, the total count of people has to be a multiple of 4. In A and B combined, the total count of people has to be a multiple of 4. And if it has to be a multiple of 4, the total number of members lies in this range. It can only be 36 or 40 or 44. 36 or 40 or 44. Okay. Once you are able to narrow it down to these 3 are the only possibilities for total count of people. These 3 are the only possibilities of total count of people. We can happily go about doing our work. Let's say the total count of people was 36. So, what is happening? If some members in B join A, the number of members in A is 3 times the number of members in B. So after the first case, I would have 27 and 9 from initial. Let's say X and Y. After the first iteration, I would reach 27 and 9. And in the second case, I would reach 18 and 18, both those groups becoming equal. Now see the interesting thing. From something is being added in X to get to 27. Something is being subtracted from X. This is group A, this is group B. Something is being added in X to make it 27, and something is subtracted from X to make it 18. Or this gap here, 9 is equal to 2A, which means A is equal to 4.5. Now the count of people can never be decimals. The count of people can never be decimals. So when total people is equal to 36, this is an unacceptable case. How about when total count of people is 40? Group A, Group B, initial, first, after the first switch, and the second iteration, what happens? After the first switch, the count will be 40 and 10. Second iteration, it will be 20 and 20, not 40 and 10, 30 and 10. Now, see, again, the switch here will of course be 2A only. This is X plus A. This is X minus A. So 2A is equal to 10 or A is equal to 5, which means originally A had 25 people, B had 15 people. A had 25 people, B had 15 people. If 5 people from B joined A, it would become 3 times of the count of people in B. Or if 5 people from A joined B, they would have equal number of people. Yes, all conditions are met. Therefore, the final answer to the question, find the number of members in B, can happily be talked of as 15. Final members in B can happily be talked of as 15. Now, for sake of completion, we will also go ahead and write it down as check for 44. For 44, A, B, L, first, and second, 33, 11, 22, 22. Hopefully, you can see 2A will turn out to be 11, or A will turn out to be 5.5. We cannot have people in decimals, which will make this case unacceptable. The answer to the question is, of course, option A, 50. Next question now. Nikhil went to a stationery shop and bought erasers, sharpeners, and pencils. The cost of each eraser is 2, of each sharpener is 3, and each pencil is 5. He spent 35 rupees for these and bought at least one of each item. The maximum number of sharpeners he could have bought is. Yeah. E, S, and P. E plus S plus P is equal to not known. We don't have count of this. But the amount of money spent is 2E plus 3S plus 5P. Now there was a condition. He bought at least one of each item. A plus 1, A plus 1, and C plus 1. Let me go ahead. Let me go ahead and buy one item of each kind. One item of each kind. So I will have 2A plus 3B plus 5C equal to 25. 2A plus 3B plus 5C is equal to 25. This much I know. And now I want B to take the largest possible value because I want to maximize the number of sharpeners that he has. Now B, under 25, the highest multiple of 3 that exists is 24. If B is 8, can I have some compensatory value of A and C to make it 25? No, this doesn't work. How about B being 7? If B is 7, I reach 21. I need 4 more, which I can do with A being 2 and C being 0. So yes, this is perfectly all right. If A is 2, there are 3 erasers. If B is 7, there are 8 sharpeners. If C is 0, there is 1 pencil. So maximum number of sharpeners he could have bought is 8. This is the best case possible. Next question. In a vehicle showroom, there are only 2 types of vehicles: 3-wheeler auto rickshaws and 4-wheeler cars. If we count the total number of wheels, there are 550 wheels, but 160 vehicles to show. And find the number of auto rickshaws in the showroom. Okay, the answer to the question is 90, and I will first try to solve it verbally so that you can visualize it. See, there are 3-wheeler auto rickshaws and 4-wheeler cars. There are 550 wheels and 160 vehicles. I'm saying start off by assuming all 60 vehicles, all 160 vehicles were three-wheelers. You would see how many wheels then? 480 wheels. All 160 vehicles were three-wheelers. You would see 480 wheels. Now, every three-wheeler replaced with a four-wheeler. Every three-wheeler replaced with a four-wheeler increases my tire count, increases my wheel count by one. Currently, I'm at 480. I have to get to 550. I need to make 70 such replacements. So out of 160 vehicles, 70 are four-wheelers, 90 are auto rickshaws, and my question is done. Now, let's try to solve it equation-wise. Three-wheelers, let's call it T. Four-wheelers, let's call it F. So T plus F is equal to 160. 3T plus 4F is equal to 550. Even I want to calculate only the count of three-wheelers. Let me multiply this equation by 4. So 4T plus 4F is equal to 640, which gives me T is equal to 90. Which is of course the same thing that we are getting here. Okay. Next question. The cost of 1 dozen apple and 1 kg orange is 20 rupees. While the cost of 1 dozen orange and 1 kg apple is 16 rupees. Also, the cost of an apple and an orange is rupees 3. If 1 kg of apple and 1 kg of orange have M and N are integers of the same kind of fruits respectively, the minimum value of M will be. Okay, look at this. 1 dozen apple plus, or let me not write it as 1 dozen apple, let me write it as 12 apples plus 1 kg orange. This is equal to 20. And 1 dozen orange. 12 orange plus 1 kg apple. This costs rupees 16. We've also been told 1 apple plus 1 orange is equal to 3 rupees. Now, if I went ahead and multiplied this equation, this one here with 12, I will get 12 apples plus 12 orange is equal to 36. And now if you combine these two, what we get is 12 apple plus 12 orange plus 1 kg apple plus 1 kg orange. This is equal to 36. Now see, these two things are already equal to 36. 12 apple and 12 oranges are already equal to 36. What this implies is 1 kg apple plus 1 kg orange is equal to 0. And this is an unacceptable situation. This is an unacceptable situation. How can something be, the price of something be equal to 0 when 1 dozen of them costs something? Therefore, the answer to this question has to be option D, data inconsistent. Next question. 3 friends returning from a movie stopped to eat at a restaurant. After dinner, they paid their bill and noticed a bowl of mints at the front counter. Sita took 1/3 of the mints and returned 4 because she had a momentary pang of guilt. Fatima then took 1/4 of what was left, but returned 3 for a similar reason. Ishwari then took half of the remainder, but then threw back 2 into the bowl. The bowl had only 17 mints left when the raid was over. How many mints were originally in the bowl? Now see, the answer to this question is very, very easy to reach. And it is entirely here. Sita took 1/3 of the mints. So the original number of bits, the original count of bits has to be a multiple of 3. Given that all the options mentioned here are non-multiples of 3, the correct answer here, of course, has to be none of these. Because initially, the total number of mints have to be a multiple of 3. You cannot take 3.2 mints. Now, that said, if you somehow wanted to calculate, if this was given to us in a theta form, with no options, how would we go about it? This is where you apply the concept of backtracking. You should be solving it backwards. Now see, finally, there were 17 minutes. But what was the last step? In the last step, Ishwari had thrown back 2 into the bowl. So prior to this, the final step, 2 was thrown into the bowl. So prior to this, there will be 15 minutes. And when were 15 minutes left? When Ishwari had taken half of the remainder, Ishwari had taken half, then 15 were left. Which means prior to Ishwari throwing back 2, there must have been 30 minutes left. Because if half is taken out, then 15 is left. So from 15, if you want to go to the prior number, it has to be 30. So when Ishwari came in, 30 minutes were there in the board. She took 15 and then she threw back 2. So essentially, she has taken 13. She has left 70. This is what happened with Ishwari. So when Ishwari arrived, 30 were left. So there were 30 there after Fatima. Had taken 1/4 but returned 3 for a similar reason. So she had returned 3 prior to Fatima returning. There must be 27 left, 27 minutes left here. 27 plus 3 gets me to 30. And this 27 was 3/4 of what was present originally when Fatima had walked in. Which means originally when Fatima had walked in, there were 36 minutes available. She took 9, then she threw back 3. So she has taken 6, left 30. Okay. Now even prior to this, Sita, what did Sita do? When Sita left, there were 36 minutes left. What did Sita do? She had taken 1/3 initially, but returned 4. So if she had returned 4, prior to her returning 4, there must be 32. There must be 32 minutes left. Now Sita had taken 1/3 of the minutes. So how many minutes were left prior to her taking the 1/3 minutes? It must be 48 minutes were there initially. When Sita walked in, there were 48 minutes there. She took 16, threw back 4. She took 16, threw back 4. So she took 16, threw back 4. So she's taken 12 and 36 minutes are left finally. So Sita took 12 minutes, Fatima took 6 minutes, Ishwari took 13 minutes, and initial number of minutes were 48. Precise answer to the question is, of course, 48. But because we could have arrived at the answer for this specific question with the options given very, very quickly, answer has to be none of these. But in case we wanted to calculate the precise number, we can also go backwards and reach the answer. Next. A shopkeeper can buy X number of pencils and Y number of pens in 1,000 rupees. Cost price of a pencil is 30 and that of a pen is 20. He gifts away a few pens and sells the remaining pens at 25 each and pencils at 35 each. If he does not make any profit or loss in this transaction, then which of the following relations can be correct? Okay. See what has to happen here. Pencils and pens. But pens are not the same pens. All pens are not being treated. Some are gifted, some are sold. See, so I had X pencils and Y pens, but I will go ahead and write it as A gifted and B sold. A gifted and B sold. A plus B is Y. A plus B is Y. So now CP for every pencil was 30. For every gifted pen, the CP was 20. For every sold pen, the CP was 20. Selling price for every pencil was 35. For every gifted pen, the selling price was 0. And for every sold pen, the selling price was 25. Now, understand this. What are we told? Profit for every pencil is 5 rupees. Profit for every gifted pen is minus 20. And profit for every sold pen is 5 rupees. So, can you see, given that he does not make any profit or any loss, can I say 5x minus 20a plus 5b is equal to 0, or x plus b has to be equal to 4a. X plus b has to be equal to 4a. Okay. Apart from this, what all do I do? I of course know a plus b is equal to y. So can I go ahead and say a is equal to y minus b? And put that down here perhaps. X plus b is equal to 4y minus 4b, or x plus 5b is equal to 4 by. This I am getting as a new expression. Okay. I also know x plus y is equal to, sorry, not this, 30x plus 20y is equal to 1000. So I can get rid of 0 straight away. I can now have 3x 1000 minus 3x is equal to 2y. Why I am making this expression is I can replace 2y here directly in terms of x. We can replace 2y here directly in terms of 2x. Okay. Sorry, 2y. So 4y. This gives me not 1000, it's 100. 2y is 100 minus 3x. Okay. So now from here I will get 4y is equal to 200 minus 6x. In replace that here, I will get 7x plus 5b is equal to 200. 7x plus 5b will be equal to 200. Okay. Now, I finally need x plus y. Which of the following can be correct? So, I can have x plus a plus b is equal to some number. This is being sorted. Okay. All the possible solution sets that I can get from here. I know x has to be a multiple of 5 from here. This is a multiple of 5. This is a multiple of 5. Can this be a multiple of 5? Let's go ahead and check. From here, if I take x as 5, 35 I get. So 165 divided by 5. 165 divided by 5 will be 33. 5 and 33. This is possible. But then also see, x plus b has to be a multiple of 4. So this is not an acceptable case because x plus b also has to be a multiple of 4. 33 plus 5 is 38. So this is an unacceptable case. Cannot have this. Next case would be when x is 10. 70 will be left with 130. 130 divided by 5 is 26. This is acceptable because here, see, x is 10 B as 26 gives me 36, which gives me A as 9. So I get 10 plus 9, 19, 19 plus 26, 45. So this is a valid expression. Okay, next case will be 15 and 7 less 19, 34, not a multiple of 4, not great. How about 20 and 12, 32, so 8. This is 20, this is 12, this is 8, 40, it can be equal to 40. Okay. The next case that I can make here is 25, 5, 25 and 5. But that will add up to 30 only, which is not a multiple of 4. I cannot make any further cases because B cannot go down any further. So the only two acceptable cases are these. I can either get 45 or I can get 40. I can either get 45 or I can get 40. So among these, which of these relations can be correct? Only 3 can be correct. You can also go ahead and plug in the numbers and check. But this would be the entire working. For gifted pens, you have to do separate working. For sold pens, you have to do separate working. Okay, next question. Some children stand in a queue and share a box of chocolates in such a manner that child 1 takes 100 chocolates plus 1/10 of whatever remains in the box. Then child 2 takes 200 chocolates plus 1/10 of whatever remains. Then child 3 takes 300 chocolates plus 1/10 of whatever remains. And so on for each child in the queue. It turns out that each child gets the same number of chocolates. Then, so on and so forth, these options are given. Now see, here also people are doing it in the same manner. They're taking something and some extra work is happening. Here also the same thing was happening. The only difference is here we had the final number 17 minutes were left. Here we don't have a final number available. Because we don't know the number of kids. Even if we had the number of kids, we could have perhaps stated the kid takes these many chocolates and 1/10 of whatever remains, something along those lines. But then because we don't know the number of kids, we don't know the final number of chocolates left. So we can't really work our way backwards. Here, taking a variable right at the beginning is important. So I take a variable, let's take, there were X chocolates. So the first kid, initially there are for these many chocolates. So first kid has taken 100 plus X minus 100 into 0.1. First kid has taken these many chocolates. Which will be equal to 100 minus 10 plus X by 10, which is equal to 90 plus X by 10. These many chocolates the first kid would have taken. So how many chocolates are left? Left would be 9 by 10 X chocolates minus 90. 1/10 gone, so 9 by 10 X left and 90 chocolates. Now the second kid would have taken how many? The second kid has taken 200 plus 1 by 10 of 9 by 10 X minus 90. Oh, it's not even 90. Minus 90 minus 200. These many chocolates are left when the second kid came. Now the second kid has taken 200 chocolates plus 1/10 of whatever remains. So from the initial count, these 200 are gone and then 1/10 has been taken by the second kid. So how many chocolates did the second kid take? 200 plus 9x by 100 minus 290 are, so minus 29. So the second kid has taken 171 plus 9x by 100. The second kid has taken these many chocolates. The first kid has taken these many chocolates. Now we are told every child gets the same number of chocolates. These two expressions I can equate. 90 plus x by 10 is equal to 171 plus 9x by 100 or x by 100 is equal to 81 or x is equal to 8100. So now see, first kid has taken 8100 chocolates. Sorry, initially there were 8100 chocolates. Initially there were 8100 chocolates. So how many chocolates did the first kid receive? How many chocolates did the first kid receive? The first kid got 90 plus x by 10. 810. So first kid got 900 kid chocolates. First kid got 900 chocolates. Total, there are 8100 chocolates. Every kid is getting 900 chocolates. So there must be 9 kids getting 900 each. There must be 9 kids getting 900 chocolates each. Let us now go and check the options. There must be exactly 7 children in the queue. No. Each child must have received 900 chocolates. Yes. The total number of chocolates initially in the box must have been 6300. No. And both A and B are true. No. The correct answer is, of course, option B. Next question. Which of the following conditions must PQR satisfy so that the following system of linear equations, linear simultaneous equations, has at least one solution such that P plus Q plus R is not equal to 0. Okay. Forget everything else. All you have to do is simply look at these terms, 5P, 2Q and R, because every option has the same thing. 5P will be what? 5x plus 10y minus 15z. This is 5P. 2Q will be how much? 4x plus 12y minus 22z is equal to 2Q. And R is given as is x minus 2y plus 7 plus 7 z is equal to R. Now, I simply have to see what sort of relation do I put between them so that I get 0 everywhere. Here I have 0. 5P, something interacting with Q, something interacting with R, I'm getting 0. Here also I should be getting 0. I see a 5 here. I see these two will add up to give me 5. So 5x minus 4x minus x is fine. But let's see if that works out well. Minus, minus. This will also turn minus. This will turn plus. This will turn plus. This will turn minus. 10 plus 2 minus 12. Yes, 0. 15 minus 7. Minus 15 minus 7 plus 22. Yes, everything works. So my final expression has to be 5t minus 2q minus r is equal to 0, which is indeed given by option A. So that will be the answer. Okay. Next. Every 10 years, the Indian government counts all people living in the country. Suppose that the director of the census has reported the following data on 2 neighboring villages, Chota Hazri and Mota Hazri. Chota Hazri has 4,522 fewer males than Mota Hazri. Mota Hazri has 4,020 more females than males. Chota Hazri has twice as many females as males. Chota Hazri has 2,910 fewer females than Mota Hazri. What is the total number of males in Chota Hazri? Okay, let's start writing stuff now. We have Chota Hazri and Mota Hazri. We have males and females. I should ideally be starting off with Chota Hazri is twice as many females as males. So let me put down Chota Hazri is 4,522 fewer males than Mota Hazri. X plus 4,522. Mota Hazri has 4,020 more females than males. 4,020. This number plus 20. So x plus 2, 4, 5, 8. X plus 8, 5, 4, 2. And then Chota Hazri has 2,910 fewer females than Mota Hazri. So minus 2,910. X plus how many? I've read this line, I've read this line, I'm directly reading this line. 2, 3, 5 minus 4 gives me 6. 7 minus 2 gives me 5. X plus 5, 6, 3. Now, we are also told Chota Hazri has twice as many females as males. This line tells me females in Chota Hazri is 2x. Females in Chota Hazri is x plus 5632, and also it is equal to 2x, which should mean x is equal to 5632, or the answer to the question has to be option C. Next one now. This is a fairly popular question in the fairly popular setup. Hopefully, this solving that I will do step by step, you will understand what I'm trying to get. A test has 50 questions. A student scores 1 mark for correct answer, -1/3 for a wrong answer, and -1/6 for not attempting a question. If the net score of a student is 32, the number of questions answered wrongly by that student cannot be less than. One way of solving it is, of course, correct questions, let that be A. Wrong questions, let that be B. Unattempted questions, let that be C. So A plus B plus C is equal to 50, and A minus B by 3 minus C by 6 is equal to 32. Now, this is these two equations. You can go ahead and find acceptable cases, which should be manageable to do. I can happily directly subtract stuff. A minus A, B minus B by 3 will give me 4B by 3 plus 7C by 6 is equal to 18. It will then give me 8B plus 7C is equal to 108. 8B plus 7C is equal to 108. Now, if I'm looking for solution sets here, first thing I see is this is a multiple of 4. This is a multiple of 4. This here is a multiple of 4. This here is a multiple of 4. So C should always be a multiple of 4. So when I start checking C, the first value I put down is C equal to 4. When it is 4, this will be 28. So B will be 10. This is a perfectly acceptable case. 10 and 4, 14 here. So how many correct? 36. Because A plus B plus C is 50. Next case that we can get from here is 4 will increase by 8 and 10 will reduce by 7. So this becomes 3. This becomes 12. 7 into 12 is 84. And 3 and 12, 15. So this will be 35. And these are all the solution sets that you can get. Now, if the net score of a student is 32, the number of questions wrongly by that student cannot be less than. Because these are the only acceptable solution sets, the number of questions wrongly answered by that student cannot be less than 3. This is one way of solving it. This is absolutely one way of solving it. Another way of solving it, the one that I like, because that also enables me to get to acceptable scores and everything. And I really have to write very little down. Hopefully this solution or this idea is clear. The other way is, first thing, I hate numbers in fractions. So first thing I'll do is I try to turn everything into a integer. How can I do that? Let's give for every correct question, for every correct answer, get +6. For a wrong answer, you get +2. And for every unattempted, sorry, not +2, -2. And for every unattempted, you get -1. Basically, every score I have multiplied by 6. And what this would also do to your final score is 32 into 6 would happen. 32 into 6 is 192. The score would have become 192 right now. Okay. Next step. Next step. Now see, I also hate 3 variables being in reckoning. So for every question, I'm giving 1 bonus marks. So now for a correct question, you get 7. For a wrong question, you get -1. And for an unattempted question, you get 0. For a correct question, you get 7. For a wrong question, you get -1. For an unattempted question, you get 0. And what would your final score happen? Because for every question you are getting 1 bonus mark, your final score will now turn to 242, 50 more. There were 50 questions. So your score has gone up by 50. Now, for every correct question, you get 7. For every wrong question, you get -1. See, the framework has now turned to, for every correct question, you get 7 correct, you get 7. For every wrong question, you get -1. Now, all I have to do is 242 divisible by 7? No, I see this is a 7n plus 4 kind of number. This is 7n plus 4 kind of number upon division by 7. This leaves a remainder 4. So what is the next multiple of 7? The next multiple of 7 is 245. Why I'm concerned with multiples of 7 is I can obtain this score with correct answers. I can obtain this score with just correct answers. But in order to move from 245 to 242, I need to do a -3. And where do I get minus? In my current version, I only get a negative score when I get something wrong. How many questions do I have to get wrong? 3. This is the minimum possible number of incorrect answers that I have to give. It's the minimum possible number of incorrect answers I have to give in order to get to my desired score. The answer to the question is 3. This is another way of thinking. The first way was simple equation based that we usually do. This is slightly more advanced. Understand, for the first thing, it will appear weird, but this working pretty much happens in my head. And therefore, as soon as I reach 242, then my work is simply to see next multiple of 7. Okay, 245, 3 again. So 3 wrong questions I definitely do. This working does not take time. Okay, next question. In a test paper of 3 papers, A, B, C, a student attempted 20 questions put together. Papers A, B, C offer 25, 20, 25, and 30 marks respectively for each answer, and no negative marks for an unattempted or a wrong answer. Then the number of ways in which a student can score 520 marks and the maximum number of questions attempted by a student in section A is respectively. Okay. So I have, let's say the number of questions attempted here were X, number of questions attempted here, correctly attempted here were X, correctly attempted here was Y, and correctly attempted here was Z. Okay. So I've got, let me see if the wording of the question is correct. X plus Y plus Z is equal to 20. The kid has attempted 20 questions in all. Additionally, the marks obtained is 20x plus 25y plus 30z is equal to 520. I can get rid of 5's everywhere. This gives me 4x plus 5y plus 6z is equal to 104. Okay, absolutely brilliant. Now, understand, I have to find out how many solution sets are possible. How many solution sets are possible? I also have to find out the highest possible value for x. The highest possible value for x. Because I have to find out highest possible value for x, I don't want to eliminate variable x. I will go ahead and eliminate variable y. So I get from here 5x plus 5y plus 5z is equal to 100, which gives me z minus x is equal to 4. Z minus x is equal to 4. Okay. Correspondingly, I can also get to y. Correspondingly, I can also get to y. So, number of solution sets. I know that z and x, best case I can think of is 4 and 0. 4 and 0. This is perfectly all right. And correspondingly, y will be 16 because x plus y plus z is 20. This way it can be done. Next is 5, 1. This will become 14 then. Then 6, 2. This will become 12 then. Then 7, 3, 10. You can go on to see the z and x will continue to rise. They will continue to increase. What will continue to decline? Y. So there is going to be a portion where we have 0 here. There is going to be a portion where we have 0 here. And z will be what then? 16. Not 16. The gap is 4. This will be 12. This will be 8. 12 minus 8. Or for sake of clarity, let me write down every case. 8, 4, 9, 5, 10, 6, 11, 7. These are all the 9 cases, and the maximum possible value of x is going to be 8. The maximum possible value of x is going to be 8. And there are 9 such cases. There are 9 such cases, and the maximum possible value of x is 8. So the answer to the question has to be option C. Okay. This final question. A telecom service provider engages male and female operators for answering 1,000 calls per day. A male operator can handle 40 calls per day, whereas a female operator can handle 50 calls per day. The male and female operators get a fixed wage of 250 and 300 per day. In addition, a male operator gets 15 rupees per call he answers. So his daily income 40 into 15, 600, 600 plus 250, 850. And he answers, and a female operator gets 10 rupees per call she answers. So 50 into 10 is 500, 500 plus 300, 800. So every male gets 850 rupees per day, every female gets 800 rupees per day. To minimize the total cost, how many male operators should the service provider employ, assuming he has to employ more than 7 of the 12 female operators available for the job? Okay. So this gives me females. The count of females that can be employed are 8 or 9 or 10, 11 or 12. This is guaranteed. Let's say he hires N males and F females. So we have two equations created. 40M plus 50F is equal to 1000. Or I can simply nullify it to 4M plus 5F is equal to 100. This is the first constraint. Now the payment that is made to them, the amount that is paid will be for every male employee, say he gets 250 as fixed and 15 into 40, so 600 plus 250, 850M. 850M. And for every female employee, 300 plus 10 into 50 plus 800F. 850M plus 800F. This is the amount that we are looking to minimize. Given that we already have the possible count of females, within these options, one wonderful thing you can see. See, 4m and 5f. This is a multiple of 4. This is a multiple of 4. So 5f should also be a multiple of 4. And among these, the only options that are multiples of 4 are 8 and 12. So I can happily go ahead and place that down. If I put f as 8, when f is 8, 4m plus 40 is equal to 100. So m will be equal to 15 here. M 15, f equal to 8. This is one acceptable case. Another acceptable case would be, and m will be 10 and f will be 12. I've done the calculation in my head. Hopefully it is not a problem. 5 into 12 is 60. 100 is 60. Yeah, so yeah, 40. 4m is 40. So m will be 10. These are the only two cases we have to check for. Let's go ahead and check. For the first one, we get 8 into 8. So 6400 plus 15 into 85. So 1, 2, 800 into 15. 800 into 15 is 12,000. 800 into 15 is 12,000 plus 750. 50 into 15 will be 750. So this is the amount in case 1. Let's add it up. 750 plus 400. How much will I get? 0 plus 0 plus 0 plus 0. That's 5. Four plus 7 is 1. 1. Then 6 plus 12. 19150. Okay. 19150. This is in case 1. In case 2, how much would he have to pay? 8,500 plus 9,600 or 18,100. Here you would have to pay 8 into 800. See, this number I'm certain of. So how many males should he employ? Final question was, to minimize the total cost, how many male operators should the service provider employ? The answer is option D, 10. In this case, I'm unable to figure out why is my number turning out to be a bad one. Is it really turning out to be a bad one? Not really. It is fine. 18,400 plus 750. No, it is fine. Everything is fine. These are the two costs that will be incurred. Of course, because it's looking for the lower cost, it has to be 18,100. And when 18,100 is being incurred, at that time there were 10 males hired. So the correct answer will be option D. And that is the entirety of this week's questions. Hopefully some new ideas, some new things. There were some simple questions also included, like this one, but then this was included for the purpose of showing you how this can be done mentally. Then there was also this question in which an alternate style was talked of. Hopefully you learned something. Hopefully the style of counting, the style of making sure that all cases are covered is something we learned. That will be all for this week. Have fun. Okay, bye.